So how this ties to what we've been doing in this chapter is proportions itself. Is once I determine that two shapes are similar, then I can use proportions to solve for missing sides of the shape. So what's important here is making sure you're careful that the sides are matching up. So, and for instance, number one, if I know that these two, they're facing the same direction and whatnot, this side matches this side and the base matches the base of this one. So if I look at number one, lots of ways to set this up, to be quite honest, where you have to be careful. Like, let's say which shape has both numbers given, like there's not a missing side. Well, that would be this one. So I'm going to use that as my first ratio, 4.5 over 6. And then I have to find where 3 and x go in this shape. Well, where would 3 go in accordance to 4.5 and 6? Well, 3 has something in common with 4.5. 3 is the same side of 4.5, so 3 would go there. Whereas x would go at the base where 6 is, because those two are the same side, matching side, if you will. And then we're back to what we've been doing for the last week. I'm going to cross multiply, so 6 times 3 is 18, and then I'm going to divide by 4.5. If I move the decimal place over, I've got to figure out how many times 45 goes into 180. 45 does not go into 1, it does not go into 18, so I'm going to guesstimate that 45 goes into 180 maybe 3 times. And let's see, that's 135. If we try 4 times, that's exactly 180. So my missing side would equal 4. Let's do that again. Number 2, same thing. If I were to match sides, this side would match that side, and the left side would match the left side. If I do my fractions, I know that these two are the only ones given, so 6 over 15. And then if I figured out where 25 and x go, where would 25 need to go? It would need to go next to 15, because 25 and 15 are the same matching side, whereas x and 6 are the matching side. So then I just multiply. 25 times 6 would be 150. And then I'm going to divide by 15. 15 doesn't go into 1, but it goes into 15 once. And then the 0, which would mean 15 goes into 0 0 times. So this missing side, x, is equal to 10. Same thing here. Be careful on these because they do tend to flip or turn different shapes. So x actually corresponds to 4. 4 corresponds to 2. And then 10 corresponds to 5. Now this one has more information than I need. For instance, I have to make sure that one of my fractions involves the orange here. So I need to use the 4. And it does not matter whether I use the 10 or the 4. Let's just say within this question, it doesn't matter if I use the 2 or the 5 for this case. So I can use 4 over 5. And then if I look at it, 4 over 5, over here on its matching side, x would go with 4, and then 5 should go with 10. So then I can cross multiply. 10 times 4 is 40. 40 divided by 5 is actually 8. And that's my missing side. Next one, if I were to match my sides carefully. Oops, sorry. Okay. I have my first fraction could be 9 over 12, and then 9 corresponds to x and 12 corresponds to 20, and then I cross multiply. 20 times 9 is 180. Divide by 12. 12 doesn't go into 1, but it goes into 18 once, which would be 60, and 12 times 5 is 60, so x equals 15. Next one, and it gets pretty repetitive. The main thing is just setting it up carefully because it does tend to turn shapes, and so you got to be careful there. Oops. All right, so for instance, this one, again, lots of ways to think about it. For instance, if I need x to be within my ratio, I'm going to just choose x over 4. And so x over 4, x corresponds to 8, and 4 corresponds to 6.4. And then I just cross multiply. 4 times 8 is 32. I'm going to divide by 6.4, which means move the decimal over. 64 does not go into 3, and it does not go into 32. So I'm going to guesstimate that 64 goes into 320. Too many there. Oh, exactly 5 times. So this missing x is equal to 5. And then it just gets repetitive. Make sure, I color code things to help me with the math to make sure that my matching sides are perfect. All right, so the main thing I want to shift gears on this one is I need to make sure that my first ratio involves x. And so x would, and I can choose either between 21 or 6 here. If I choose 6 to get a smaller number, that means next to x would have to be 30 because those are my corresponding sides. And then 6 would have to correspond to 8. So then I do 30 times 6, which is 180. I'm going to divide by 8. 8 does not go into 1, but it does go into 18 2 times, which is 16. Subtract that, and I get 20. 8 goes into 20 2 times, which is 16 again. And then I bring down I have to add a decimal and a 0. 8 goes into 45 times, so it'd be 22.5. And then again, just repeating steps 1 through 3. Now this one I do want to talk about. In this particular case, if you look at it, this shape has 4 numbers and this shape has 3. Which one of the numbers could I not use? Well, I can't use 4 because it doesn't have a corresponding side. So I've eliminated that. Then just remember, I want to use x as one of my terms. And I can decide between 11 and 13.2. And it just comes down to preference. Like if I don't want to use a decimal, so I'm going to use 11. That means on my other ratio, x corresponds to 3. And 11 corresponds to 5. So I have 11 times 3, which is 33. And I'm going to divide by 5, which goes into 33 6 times. And then I have to put a decimal and a 0. So 5 goes into 35 times. So x would be 6.5. This one is probably the trickiest I've ever seen. How this works if you crisscross like that is actually x corresponds to 20 and 30 corresponds to 24. So think of it just like crisscross there. So x would go to 30 and then x corresponds to 20. So 20 needs to go next to x and then 24 corresponds to 30. So then when I cross multiply, 30 times 20 is 600, which then I'm going to divide by 24. 24 does not go into 6, but it goes into 62 times, which is 48. Then I subtract that, would be 12. Then bring down the 0 would be 120. And 24 goes into 125 times, I believe. Yep, exactly 5 times. So it would be 25. And then it just repeats. All right, and if I need my first fraction to have the x would go with 6, and then on the corresponding sides, x goes to 30 and 6 goes to 18. 30 times 6 would be 180, and then 180 divided by 18 would be exactly 10. Now I just want to show you these where maybe the trickiest of them all is a shape within another shape. So if you look at number 10, you see the small triangle in this section, and then you see the big triangle outside of it. So this is where it can get a little messy. Oops, I'm trying to push it, sorry. All right, so that being said, x still needs to be a part of my ratio. So x over, let's say 6, because that's both the small triangle. And then I do x corresponds to 20 and 6 corresponds to 15. So not too terrible on that one. 20 times 6 is 120. I'm going to divide by 15. 15 does not go into 1. And it does not go into 12. 15 goes to 120, I believe, 4 times. Nope. 8 times. It goes into 128 times, so x equals 8. Not too messy, right? But this is where number 11 gets tricky. So if I look at number 11, okay, x does go to 9, okay? But right here, 3 does not go to 4.5. 3 goes to the length of this entire triangle. So I have to figure out what that entire side of the triangle is by adding. 3 plus 4.5 is 7.5. So that's where I don't actually use 4.5. I'm going to use 7.5. Now I can't use 2.5 because I don't know what that dimension is. So x corresponds to 3 because that's the small triangle, versus x corresponds to 9 and 3 corresponds to 7.5 like we determined. 3 times 9 is 27. Then I'm going to divide by 7.5 by moving the decimal place over. 75 does not go into 2 or 27. So I have to figure out how many times 75 goes into 270. Which would be 3 times. If I subtract 270 and 225, that would be 45, which means I had to put a decimal and a 0 to continue. If I try to do 75 and 450, too large. Oh, there it is. It would be exactly 6. So this would be 3.6 as x. Same thing on this one. So 24 does correspond to x, but 20 on the small triangle does not correspond to 12. It corresponds to the summation of 20 and 12, which would be 32. So I don't use 12 at all. 12 just helps me figure out what 32 would be, that long side. So x actually goes to 32, where x would need to go next to 24, and then 20 would go with 32. So then I cross multiply. I've got 32 times 24. Which would be 768, and then I'm going to divide that by 20. Which would be 8 times, which would be 160. Got to put a decimal and a 0. So 20 goes into 84 times. So it'd be 38.4 as my side.